In this video, I will do some mole-to-mole stoichiometry problems to get some practice with this one-step conversion. Here we are given the equation where hydrogen gas and oxygen gas react to form water. It's already balanced for you. It has the 2 in front of H2 and the 2 in front of H2O. And so this is a balanced equation. The question asks us how many moles of oxygen gas must react to create 7 moles of water. So the first thing we do is on our equation at the top, we're going to mark it with what we're looking for and what we're given. So the question says how many moles of oxygen gas. So above O2, I'm going to put a question mark in moles. This reminds me that that's what I'm looking for, and the unit I should end with is moles. It also says in the question, I want to create 7 moles of water. So since H2O is water, on top of H2O, I'm going to write 7 moles. For this step, the fact that O2 doesn't have a coefficient or has an imaginary 1 and H2O has a 2 in front is not the issue. We're only looking at what the question tells us. The next thing we're going to do is set up a T chart. It's kind of like using ratios or fractions, but it's a little bit easier to set up. So for a mole-to-mole conversion, we just need 1 T. And the first thing we always do is we take whatever value was given to us, 7 moles of H2O, and we put it in the upper left. And this is true even as we get to the harder problems. We're always going to put the given in the upper left. Now it's really important to put H2O there because it's not just 7 moles of anything, and it's definitely not 7 moles of hydrogen or oxygen. The given value was 7 moles of H2O. Now, given that this is like fractions, moles of H2O is on the top, but the answer we want is moles of O2. So we need the words moles H2O to cancel. So I'm going to put them on the bottom. So now you can see that moles H2O is on the top and the bottom, so those will cancel out once I do this correctly. The words that I want to end with, that I want my units to be, are moles of O2. So I'll put those on the top so that they don't cancel out with anything. Now the question is, what numbers should I put there? This is the time when the coefficients, or the numbers in front, matter. So in front of H2O, there's a 2. And in front of O2, there's an invisible 1. So with H2O, I'll put a 2. And with O2, I'll put a 1. Now we're going to continue to treat this like fractions. So you're going to take the numbers on the top and you're going to multiply them. So 7 times 1 is 7. And the numbers on the bottom, which in this case is only a 2, but you would multiply them. So we have a 2. So we have 7 divided by 2. Now to check that we did this right, we want to make sure that moles H2O cancels out with moles H2O. And we're only left with moles of O2. 7 divided by 2 is 3.5, and our unit is moles O2. And that would be our answer. Let's try another. But before we go on, let's just clarify what this means. This means that if I use this reaction and I want to create 7 moles of water, then the only way to do that is to ensure that I put 3.5 moles of O2 into the reaction. This is basically the ratio of reactants to products, kind of like ingredients in a recipe. In this reaction, 2 moles of potassium chlorate decompose into 2 moles of potassium chloride and 3 moles of oxygen gas. The question says, using the above reaction, I produce 5 moles of potassium chloride. How many moles of oxygen gas are produced? So the first thing we're going to do, just like last time, is to label our equation. We want to produce 5 moles of potassium chloride. So that's actually our given because it's the only place in the question that we're given a value. So on top of potassium chloride, KCl, I'm going to write 5 moles. The question asks, how many moles of oxygen gas are produced? So we're going to go over to oxygen gas and put our question mark with moles. Now it's important to notice that potassium chlorate at the beginning of the equation has oxygen in it. but we're looking for something that is just what they're asking for, oxygen gas, and that's O2. You'll never be looking for more than one thing at the same time. So let's make our T-chart. And in the upper left, just like before, we put the given value, 5 moles of KCl. We know that moles of KCl has to go on the bottom so that we don't end up with those units, and that moles of O2 has to go on the top so that we do end up with those units. The number in front of KCl is a 2, so we put that with KCl. And the number in front of O2 is a 3, so we put that with O2. So the first column, this first section here, is just the given, and the second section here uses the coefficients. It's the ratio of the coefficients. So when we multiply across, we get 15, and the bottom is just 2. And we can see that moles of KCl goes away, so that we get 7.5, 15 divided by 2, moles of O2. So just to recap, we're always going to put the given in the upper left, and we're always going to have some sort of units with it. Let's call those units A. If we're trying to get rid of A and figure out B, so where A is, moles of something we were given, and B is the moles of something else, we want to make sure that we put those units down here to cancel and our new units at the top, so that you can see that those words are going to cancel. The numbers that go above the words come from the coefficients in front of the equation. So this is one of the coefficients, this is the coefficient in front of A, and this is the coefficient in front of B. And then you're always going to multiply across and then divide. And always remember to write your final units.